In this video, I'll explain the rules for current and voltage in both series and parallel circuits. Okay, let's start with a series circuit. So in a series circuit, we have some resistors, R1 and R2. Now, one of the things we can say is the current, let's call it I, going through R1, and the current going through R2, okay, it will be exactly the same. Doesn't matter where we measure it. In a series circuit, the current will remain the same, travelling all the way through. Even if we add on an extra resistor, R3, we can still say we have exactly the same current travelling through it. Current is a measure of the amount of charge flowing per second, and in a straight series circuit like this, the amount of charge flowing per second will be constant as charge is conserved. As for voltage, that's a slightly different story. In series circuit like this, each of the resistors could well have a different voltage across it. What we can say about voltage is that if we add up all the voltages, so let's call them V1, V2 and V3, there we go, that the total voltage across all of these will be the sum of these voltages. Okay, so V total will be V1 plus V2 plus V3. They may be the same. This can happen if the resistances are identical, but they may not be. And there's no reason to suggest that they will all be equal, but we can always say that the total voltage across these three resistors in series is the sum of the individual voltages, the individual potential differences across each of them. In parallel, it's a little bit different, so let's draw a parallel circuit. Initially I'll just do it with two resistors, but I'll show that we can always add another one. Okay, so we've got, right on there, R1 and R2. Okay, so we have two resistors here in parallel. Now, in this instance, if we're measuring the voltage across R2 will be identical to the voltage across R1. There's no difference, there cannot be a difference in the potential difference across the top resistor across the second resistor, and indeed if you had 3, 4, 5, 100 resistors, if they're all in parallel, the voltage across them is always the same. So, the current is a different story. If we have the current entering here, let's call it I total, that current will then split up at the junction. Some of it, I1, will travel through R1, some of it, I2, will travel through R2. The amount of the current that travels through depends on the size of the resistors. The lower the resistance, the greater the current that will flow through it. And once it's come through the resistors, again we have I1 and I2 here, it will recombine and come out as I total. Now that total is always equal to the sum I1 plus I2, and if we had more resistors we could say it's I1 plus I2 plus I3 and so on. Okay, this is Kirchhoff's first law and is one of the rules for current in a parallel circuit, that the current will split up, but the sum of all the currents leaving the junction is equal to all the current entering the junction. Okay, it is always conserved.